All right, number 2, we just want to determine the end behavior of the graph. It's already in standard form. So my leading term is positive and it is odd. Okay, so I know that when it's positive and odd, I'm looking here. So up on the right, down on the left, the signs are going to match. So when x is going to negative, the y is also going to negative. When x is going to positive, my y value is also going to positive. So even though it says k of x, you need to understand that this is x and y values, and so don't let all the letters confuse you. It's just an x and y value, and it's a direction on a graph. All right, number 3, we have 4 parts. It wants us to find the zeros, state the multiplicity, and so for this we're going to need to factor. So it says, find the zeros, we're going to factor out the greatest common factor. So that's going to be step 1. So here's number 3. We have q of x. Again, it just stands for y. X to the 6 plus 6x to the 5th plus 9x to the 4th. Now, these 3 terms have in common at the biggest is x to the 4th. So we'll factor out an x to the 4th, and that will leave me with x squared plus 6x plus 9. Now in parentheses we have a quadratic, so I'll try to factor that. 1 times 9 will give me 9. Factors of 9 are 1 and 9, and 3 and 3. We want to add factors to get a 6. That will be 3 and 3. So I can write the x to the 4th, 2 sets of parentheses, and then we'll do the x squared split up, the 3 at the back, and we need these factors to add to a positive 6, so that means they both have to be a positive 3, adding them. Okay, this is a duplicate term, so I can just really write this as x to the 4th times x plus 3 squared. And this is all set equal to 0. Now, once we have it in factor form, we can see the multiplicity. So this multiplicity means the power. Like if you have a power on a form like this, that means it's a repeated or a duplicated root, and whatever you get, that number is either 4 times 0 or 2 times 0, or whatever that is. It's the multiplicity. So x to the 4th equals 0, and x plus 3 equals 0. And we take the 4th root. Now I could have put the squared, okay? All that's going to do is take the square root, okay, just to be thorough. Square root of 0 is 0. There's no plus or minus, it's neutral. So then we just end up with x plus 3 equals 0. So I was kind of skipping the middleman, but over here we would do the 4th root of both sides to get rid of that. 4th root will behave similar to an even regular square root, plus or minus, but again 0 is neutral, so we just get x equals 0, and that's I'm going to say m4, multiplicity 4 because of that power, and then when we solve we get x equals -3, and I'm going to say m2 for multiplicity 2, so that's a 4 multiplicity and a 2 multiplicity 0. So first it wants us to factor out the greatest common factor, and we're going to say x to the 4th, and then inside of here we're going to have x squared plus 6x plus 9. And then it wants us to factor the perfect square trinomial. We got x plus 3 when we factor that. And then it wanted us to factor, set each factor equal to 0 and solve for x. So doing so, we got 0 and -3. And finally, we're going to state It says if a polynomial function has a factor x minus c that appears exactly k times, then c is a zero of multiplicity k. So that's just a mathematical context. So it says therefore 0 is a multiplicity of 4 because of that power up here. And the negative 3, which came from the x plus 3, is a multiplicity of 2. Okay, it's a double root because of the second power